Hey, good morning, everybody, or afternoon, according to when you see this video. I hope y'all had a great 3-day weekend. And I guess here we go. This is our first lesson for this week, Monday. And we were actually, if you're going by the book, section 4.6. Now, 4.6 is based on composite functions. Actually, composite trig functions, or an added trig to it. And so the word composite means to compose more than one thing together. And we're going to compose trig functions or trig functions with other known functions. So we know that when we look at a sine function, it makes a sine wave. Cosine makes a cosine wave. X squared makes a parabola. X makes a straight line. But what happens if you decide to compose two of these? What's going to happen? Is it going to stay a wave, or is it going to become a parabola or straight line, or is it going to do something really weird? Okay, and that's what we're going to determine on part 1 of today's lesson. And so what we're going to do is we're going to determine what kind of wave we have and if it's what we call periodic. All right, so we're going to go from the negative 2 pi x 2 pi. So x is going to go from the period 2 pi to negative 2 pi. And we're going to see or graph these functions as a composition, and we're going to determine, is it periodic? All right, what does it mean by periodic? Well, you're going to keep the sine or cosine wave. And it's going to have the exact same distance, amplitude. It's going to stay consistent, in other words. So this would be like periodic. This would be non-periodic. Okay, so let's say you're going and then all of a sudden it gets narrow, dips down, does something weird. That's non-periodic. Or if you get a parabola, all right, it's non-periodic because you're going to go up forever in each direction and it's not going to come back down forming a wave. So periodic, anything else, non-periodic. And what we're going to do is we're going to compose these using your TI-84 calculators. So if you haven't got your calculators, pause the video, go get your calculator, and then come back and restart it. And I'll show you how you put this in and determine if it's periodic or not. All right, so our first example. Let's say that we have y equals sine x plus x squared. So we're going to combine a sine wave with a quadratic. All right, so turn on your calculator. What we're going to do is put in y equals sine x. I'm going to close the parentheses because this plus x squared, I don't want it, together. So we'll have plus x squared graph. All right, now my calculator was zoomed in, so I'm going to zoom out. So what you want to do is hit zoom and number 3 if it's not like that. All right, and this gives me a better look. Oh, look, we have a parabola. So this would be a non-periodic. So is it periodic? Your answer would be no. Let's look at another one. Try this. Y equals sine x squared. So you're taking this and squaring it, so it's like an x squared, so it's a composition. So we want to see if this is periodic or not. Come back into your calculator and let's put in sine x, close it. Actually, I think we need to do this. Parentheses, sine x. Then I'm adding a second parentheses because we have this whole thing here, which is going to be squared. Graph. Oh, check it out. Notice that we have a wave going, and it's consistent all the way through. So therefore, class, we have a periodic wave. So your answer in this, is it periodic? Yes, it is. When you start your lesson with forms, you're going to have a few questions. Use your calculator, and then you're going to simply put in yes or no for each one of them. All right, that's part one. Let's look at part number 2. All right, I'd like everyone to go ahead and copy this composite function down. F of x is equal to 0.5x plus sine x. Now, if you were to graph this, look what would happen. You're actually not going to graph these for your answers, but I just want to show you what this looks like. So I have 0.5x plus sine x. Graph. Oh, wow. Check this out. So it looks like our graph, our sine wave, has been tilted. So apparently this 0.5x has caused our graph, instead of going straight across, it's going up at an angle. Now, what we're wanting to determine is, if y'all remember when we did this earlier with sine waves, we had an upper bound and a lower bound. Well, these upper and lower bounds are forming a straight line, of course. But we want to determine what is the equation of these lines that form the bounds. So instead of having like at 2 and -2 or 1 and -1, because that's our bounds, it's just a straight line. X equals, those numbers. What is it if it's slanted? So it's like going up at a diagonal. What is the equation of those bounded lines? And that's what we're going to determine with these equations. So actually no calculator needed on this part. And this is all you really need to know. Really, really simple. If you look at sine, we want to know the amplitude. Now, the amplitude, of course, is the number in front of the sine or cosine or whatever we had. So right in front, that is an amplitude of 1. So I would have 0.5x plus 1. So I just want to know what is my amplitude. Well, this is 1. And that would be like an upper bound. Now the lower bound would be the opposite. Okay, so this would be 0.5x minus 1. Our answer, or true answer, would be, what are the two lines that form the bounds? So it would be y equals 0.5x plus 1 and y equals 0.5x minus 1. Now let's go back to our calculator and we're going to try this out. So I'm going to keep this equation in and we're going to see if those lines actually do form. So this is y equals 0.5x plus 1, and then I'm going to come down and go 0.5x minus 1. Graph. Check that out. We just found the upper and lower bounds. So that is what we are looking for. What are the two equation bounds when the graph has been tilted sideways? And there you have it. So you're just using the amplitudes. Now it can get a little trickier, so I'm going to show you an example of one that it is slightly different. So let's say that we have f of x is equal to 2 minus 0.5x plus cosine 2x. All right, so we're going to take the sine or cosine and we're going to look at the amplitude. The amplitude is 1. So this would be 2 minus 0.5x plus 1 and 2 minus 0.5x minus 1. Oh, look, we can simplify this. See, we have a 2 plus 1, so y equals 2 plus 1, 3 minus 0.5x. 2 minus 1, y equals 1 minus 0.5x. And that would be your two equations that would create the upper and lower bound of your cosine wave. All right, let's do one more just to be sure. Let's say I have f of x is equal to 1 plus 0.5x plus 2 sine 1/2 x. All right, here's our amplitude. So we have 1 plus 0.5x plus 2 and 1 plus 0.5x minus 2. Combine these two. So I have y equals 3 plus 0.5x and 1 minus 2. So that'd be y equals negative 1 plus 0.5x. And that's all you have to do. So that's part 2. Now what you're going to do is go on to the rest of your forms, and you're going to answer each one of the questions. All right, y'all take your time, and I will see everybody tomorrow for your second lesson.